Hi, I'm Krishna from the Things Industries, and let's talk about your devices at scale. So once you get past the initial testing stage, you might have hundreds or thousands of devices that you want to work with, and you will quickly run into the problems of scale. So in this video, I will give you some information on how you can solve these problems at scale. My personal framework of looking at this is through the 3 layers of scale.
The layers of scale is a convenient framework to understand how device security works in a large fleet. The 3 layers of scale are as follows. The first layer is to manage the delivery of your device fleet. When you're a device maker, transferring a large number of your devices from your factory to your customers can be a tedious and highly error-prone task. The user then has to individually clear these devices on the network server of choice. So the Things stack provides a bunch of options to do this seamlessly. You can use CSV file provisioning or our device claiming features as mentioned in our documentation to be able to do this seamlessly and quickly. So the next level of device management is device fleet security. So it's not a good idea to send your users a file containing all the keys for all the devices. This happens quite a lot in the past, and we would want to avoid that. This is where the Things Join server comes in. Instead of sending keys to your end user, you securely provision it on the Things Join server, and then you send the devices and certain device information to the end user. So the end user then registers the device in a LoRaWAN network server, and the LoRaWAN network server talks to the Things Join server to get the device session keys. And finally, we're going to close the security loop by using a secure element. When you use a secure element, you will provision the keys on the Things Join server and send the end user a device with the secure element equipped. The secure element will make sure that the keys are secure in the hardware security module, and the entire security is now a closed loop.
Now let's look at an exclusive sneak preview into working with the CLI of the Things Join server.
The command line interface of the Things Join server is used to interact with the Things Join server, which is a standalone LoRaWAN join server implementation. The first step is to actually install the CLI. We can easily do that by using the command here. It uses npm to install the package. And once the package is installed, you can check the version using the version flag. Now, once the CLI has been installed, we have to run initialization. So let's run the init command. We need to enter the URL, which is local for me. I'm going to have the password, username and the password is given to me earlier, which I had set up on my local join server. And I'm also going to configure a network server with the NSID of 16 digits hex. And for the password, I'm just going to generate a random string. And I'm going to do the similar thing for the application server, and the ID will be localhost because the Things stack is running localhost for me. And now I'm just going to use another random value here, and it gets stored in this location. You can also see what values are stored in the configuration file by reading that file. Now the next step is to set up the network servers and the application server. This is necessary for interoperability. So I'm going to just change all the default values and make it a test network server with the NSID of 16 zeros. This has to match the value that you've used in the init, and the password, of course, was the value that we created before. And we're going to repeat this process for the application server. And in this case, my application server is running on localhost, so the ASID will be localhost. And I'm going to use the same password that I set up previously for the application server. Now, the next step is to provision devices. You can provision as many devices as you want, but we are going to, as an example, run one provisioning. So the Things Join server CLI supports 2 formats at the moment, CSV and the microchip ATEC format, which is used for secure elements. Let's see how we can work with the CSV file. I have a test CSV file right here. I will open that in a moment. And it contains the dev UI, the app UI, and the owner token. Owner token is a secret that is used to claim this device. So let's provision this device using the command that's here. I'm just going to replace the file with the file that I have. Voila, so the device has now been provisioned, and you can also see the EUI and the secret. Now we are going to set up the CLI of the things stack, because I have a local things stack running and I want to be able to claim this device. So I'm using an open source configuration, and now I will just log in on my local machine because I have a stack running there. And if you go to our documentation, you can see how you can do this yourself also. Now that I've logged in, I'm going to create an application first so that we can claim a device inside that application. So it's a test app and the user is admin because I've logged in as admin. And then I would like to create this device. Before we do that, let me show you what's in this dev.json. It is basically the device specification of a device that we want to claim and register. So the EUI should match the EUI that we have configured, and the claim authentication code should also match the value that has been provisioned. And now we can create this device on the things stack using this command. And as you can see, the things stack dials the join server and claims the device successfully. It skips registering it on the cluster join server, instead uses the standalone things join server. And the value used is secret. You can also now see the state of the claim in the things join server using this command. So let's do that. And as you can see, once we enter the EUI of this device, it has been claimed by our local things stack implementation. It has some device specific information, which we can skip for now. So voila, that's how simple it is for you to claim a device. And now we want the device to be able to send uplinks, for which we need the interoperability. Interoperability is a thing where the local host things stack will contact the local things join server and get the session keys. In order to do that, we need to do some interoperability settings, and this is defined in our documentation. I will not go through the details here because this is quite complex by itself, but all we need is a couple of secrets from this location. We need basically the keys for the network server and the application server. So let's configure that here. I'm going to set the key for the network server with the same ID, and the key label can be anything. I'm just using a hex value here, and also the key is a 128-bit AES encryption key required to decrypt the session keys. And I'm going to repeat that process with the application server and use a different key label and set the key for the application server also, so that the application server can contact the things join server and get the session keys for the device. And I'm going to use another AES 128 secret value here, which has also been configured on the things stack based on the documentation. And now this is all set, what I'm going to do is I'm going to try to send an uplink or a join request to my device. So I'm going to log into the console on my local stack, and I'm going to send an uplink, a join request, to see if the device actually joins through the new things join server. Now I have sent an uplink, and as you can see, the join request message has been forwarded. And this was because the local the device was not found in the local join server, so it went to the things join server. This does not show us a lot of information, so I'm going to repeat this process with the verbose stream enabled. And as you can see, now you can see the entire flow of how we used interoperability to join this device instead of using the local join server. Voila, so that's how easy it is for you to provision your own devices on your own join server and use the things stack for the actual traffic.
As of the recording of this video, the things join server is in pre-release testing and will be available shortly for everybody to use.